Today we are discussing about the fourth module of software engineering, that is a test cases. If you want to develop any product, or if you design any product, or if you want to run the program, we need to check whether the program is working properly or not. When relevant to the same thing, we have product also. You have to test the product whether it's working properly or not, and also you should validate and verify. That is a V and V has to be done for each steps. Then whenever you're getting a correct output, then only the test is the product is correct or not. Okay. According to this, in this chapter we are mainly concentrating on development testing, test driven development, release testing, user testing. First we'll start with the development test, the program testing. Testing is why you want, if you want to execute any program, then we need to check if you are if you want to perform any addition of two numbers, then you will give a two inputs or three input depending upon the program inputs. Then we have, after performing the addition, we need, it has to process and get the output, and it will show the result addition of two or three number. In the same way, we are testing has to intended to show the program to defects before it's put into use. What are all the defects? What are all the defects has to be identified and before your user can be used. When you, if you want to test a software, the program is using the artificial data. That is not using the regular data. That is artificial data has been used to check the result of run for the errors. If you, the program has to be executed for checking the errors. Then after, about the programs for non-functional attributes. Non-functional attributes are those, it can be relevant to the system. It can be reveal the presence of errors, not their absence. Testing is a part of some general validation process verification, which includes the static validation testing. It cannot be used for a dynamic validation. It includes for the validation techniques. Program testing tools demonstrate the any developer or the customer the software meets its requirement. Whenever the product has been designed, it has to meet the requirement of a customer. For example, any custom software, that is should be at least test for every one requirement in the requirement document. And for the generic software products, it means test for all the system features. It's a generalized one. That's why it's known as a generic system software that will be incorporate in the product release. To discover the situation in which the behavior software is correct or incorrect, it's undesirable or does not conform to its specification. It's concerned with the routing of a behavior system, such as a system crashes or unwanted interaction with the other system or incorrect computation and data corruption. That is a program testing goals. Next is in validation and defect testing. We have two different goal has mainly concentrating on that. The first one is a validation testing. The second one is a defect testing. First we'll discuss about the validation testing. It expect the system to perform correctly or not by using a given set of test cases that reflects on the system use. Then the second leads to the defect testing. This is designed to expose the defects. In defecting can be obscure or need not reflect how the system is normally used. Next is in testing process goals. In the testing process goal, first is in validation testing and next is in defect testing. In the validation testing, the demonstrator has to developer and the system customer, the software meets the requirements. The customer has given some requirement. Depending upon that, the developer has to conduct the test cases whether it's working depending upon the requirement of a user. After the successful test case, get the successful result, the system has to give for operations as for the intended. So next is in defect testing. Defect means the name itself indicates to identify the test cases with the what is its behavior is incorrect or not with its specification. What are the specification given by the customer or the user? It's working properly according to the behavior of a customer. A successful test is a test that makes a system incorrectly and also exposes the defects in the system. Just we have an example for an input output model of a program test. Just we have example of any program. What you do after executing the program, after writing the program, we need to give the inputs for the program. Then it has to, after accepting the input, it has to process and output the test result with the specified. For example, any a program, for example, if we need to calculate for simple interest, we'll give a inputs with the principal amount. To calculate a simple interest, we need to give the inputs for a principal amount, time, and as well as a rate. Then we have to get the divide by 100. Then we have to calculate in the formula. Then you will get a output. Next is in verification versus validation. V versus V. Verification. What do you mean by verification? Verification here you are pronouncing as the proverb. Are we building the product right? We have a question mark on this. Are we building the product right? It has to conform to its specification. Then for validation, are we building the right product? Okay, are we building the right product? It should do the user what it really requires. That is the difference between a verification and validation. In the aim of verification and validation is to establish a confidence in the system fit for purpose. Depends on the system purpose, user expects and marketing the environment. Environment is mainly concentrate on software purpose, user expectation, marketing environment. What is the purpose? Whenever if you design any software product, what is the purpose of the software? Whether it needs a use the customers the requirements. If it is accepts the customer requirement, the level of confidence depends on how critical the software is to an organization. Next is an user or the customer expectation. They have a low expectation of a certain kinds of software. It may be certain kinds of some of the simple software they have a low expectation. Only for few of the software they need a high expectation. Then next one is in marketing environment. If you want to open a shop, we need to check where and all we have the, if you open a shop, then whether it is a it can be affordable to all the users. We need to check the place or the environment. Getting the product market early, maybe you have to, as soon as product has been designed, you have to bring to the market early to finding the defects in the program. Next is in inspections and testing. If you want to inspect for any product or any testing, inspection, we need to keep on checking whether it's working properly or not. It's concerned with the analysis of a static system representation to discover the problems. To discover the problem, whether it is a static verification. It's a tool-based document and code analysis. Any tool-based document with the code analysis. It's a MS Excel like that. Then software testing. Then you need to check whether the software design software working properly or not. it is concerned with the exercising and observing a product behavior. That is we have observing with the time, that is given known as a dynamic behavior. It is test for operational behavior is observed. Next we have inspections and testing. It has been given in the activity diagram. Inspection has been divided into the requirement specification, then software architecture, then UML design models, database schemas, then program. For this, as it has been divided with a different inspection. First, we need to identify what is the specification of a user. Then, after finding the specification, we have the architectural diagram for that. Then it has to be applied with the unified modeling language of a model. We have to represent in a model. That is abstract representation of any system. Then database, it has to be represented either with a database, different database schemas. Then after all this has been done, then you have to run for the program. Then we have to perform in the requirement specification with the system prototypes has been finally embedded with the testing for the program and as well as a system prototype. Next, we'll discuss the software inspection. The software inspection again, you keep on inspecting. It's a aim of discovering the defects and anomalies, any defects and anomalies as executing during the software inspection. It does not require any system, so may be used before implementation. It may be applied to any representation of the system. For example, it has to be depending on the user requirements. It has to be designed, configure the data and test the data and maintenance of a data and so on. Then they have been shown an effective technique for discovering the program errors. Next is what are the advantages of inspection? What are all the advantages for checking? Anyhow, it has to the main advantage is we have to test the errors. Also it can hide the other errors because it's a static process. It can don't have to concern with the interaction between the errors. It's a static one. Then it is an incomplete version of a system can be inspected without additional cost. If a program is incomplete, then we need to develop a specialized test harness to test the parts that are available. Then we are also searching for a program defects, and inspection can also consider a broader quality of attributes such as a compliance with the standards and probability with the maintainability. What are all the inspections and testing can be done? In the inspection and testing, they are complementary. They are complement to each other and not opposing any verification techniques. Both should be used during the V&V process, verification and validation process. It can check conformance with the specification with the customer's real requirements, what the customer they want. It cannot check for a non-functional characteristics such as a performance, usability, etc.